Hello students and good afternoon. So today also I am doing class for class 2 science. The topic is first order derivative. So in the last online class also we were doing the same topic, that is first order derivative. So this is your continuation class, right? So let's do question number 18. Find dy by dx. So question number 1 is x is equal to a cos theta, comma y is equal to b sin theta. Now in the last online class I told you about explicit function, implicit function and parametric function. So what are these implicit function, explicit function and parametric function? So I told you about all these functions in the last online class. So and we did problems on how to differentiate explicit function and implicit function. So today we shall discuss about the differentiation of this parametric function. Okay. So now in question number 1 it is given x is equal to a cos theta, comma y is equal to b sin theta, and you have to find out dy by dx. So you know that x and y are the two variables, and this x and y are expressed in terms of a third variable theta. So here theta is known as a parameter. So that's why this equation is known as a parametric equation. So now in this case a and b are constant. So how can you find out dy by dx in this case? Okay. So here first equation given here is x is equal to a cos theta. That is, here x is expressed in terms of theta and a is a constant here. So let us find out dx by d theta here. So differentiating both the sides with respect to theta. Okay. So therefore dx by d theta is equal to a into d by d theta of cos theta. We are differentiating both the sides with respect to theta. Okay. So or dx by d theta is equal to a into, what is the differentiation of cos theta? It is minus sin theta. Or dx by d theta is equal to minus a sin theta. So this is number 1. Let us mark it number 1. Okay. Again, what is the second equation given here? Y is equal to b sin theta. So again, y is equal to b sin theta. Okay. So let us find out dy by d theta here. Here also y is expressed in terms of theta. So let us differentiate both the sides with respect to theta. So differentiating both the sides, with respect to theta. Therefore, dy by d theta is equal to b is constant. So it is taken outside d by d theta. So d by d theta of sin theta. So or dy by d theta is equal to, this is b into, so what is d by d theta of sin theta? It is cos theta, right? So you mark it as number 2. So now actually you have to get the value for dy by dx. Now what will you do with this 1 and 2 to get dy by dx? So this d theta should be cancelled, isn't it? So if you divide 2 by 1, you will get dy by dx, that is, this d theta will be cancelled. That means you have to divide 2 by 1, right? So therefore, dividing 2 by 1, right? So dividing 2 by 1. So what do we get? Therefore, dy by d theta upon, in the denominator you write down left hand side of number 1, that is dx by d theta, which is equal to, on the right hand side you should write right hand side of number 2 in the numerator, divided by, in the denominator you write down right hand side of number 1, that is minus a sin theta, right? So next, or now in this case d theta will be cancelled. So you will get dy by dx, which is equal to, this is minus sign, you write first minus sign, then b by a, So minus sign you can write it either in the numerator or in the denominator. Let us write it in the numerator, that is minus b by a. And what is cos by sin theta? It is cot theta. So this is the final answer. Okay? So you can copy it. I think you have understood it. So we'll do the next question now. So now we'll do the next question, that is 18 number 2. Here also find dy by dx. Number 2, x is equal to a cos theta by 2, comma y is equal to b sin theta by 2. Here also the two variables x and y are expressed in terms of a third variable theta. So here theta is a parameter, so this is also a parametric equation. So let us find out. Similarly as in problem number 1, you can do this problem. Let us find out first dx by d theta. Then you have to find out dy by d theta, right? So therefore x is equal to a cos theta by 2. So now let's differentiate it. Differentiating both the sides. Differentiating both the sides with respect to theta. Therefore dx by d theta is equal, directly we can differentiate it. Okay? This a is constant into, now you have to take it as cos theta, but theta by 2 is there. So what is the differentiation of cos theta here? Minus sin theta by 2. This is into, right? A into minus sin theta by 2 into, again you have to differentiate the term which is assumed as theta with respect to theta. That is, you have to differentiate theta by 2 with respect to theta. That is, half is constant, comes in the front, into d by d theta of theta is always 1. So it is half. Because you are differentiating both the sides with respect to theta. So this cos theta by 2, you should take it as cos theta. So what is the differentiation of cos theta? Minus sin theta. But you should write here theta by 2. Again you have to differentiate the term which is assumed as theta. In this case theta by 2 is assumed as theta. So you have to differentiate theta by 2 with respect to theta again. So what is d by d theta of theta by 2? So half is constant, you can take it outside d by d theta. So half into d by d theta of theta is always 1. So you will get only half, right? So or it is dx by d theta is equal to minus a by 2 into sin theta by 2. So let us mark it number 1. Got it? So dx by d theta is equal to minus a by 2 sin theta by 2. I think you have understood it. So similarly you can differentiate the second one. So again y is equal to b sin theta by 2. So now let us differentiate it with respect to theta. So differentiating both the sides, with respect to theta. Okay? So therefore dy by d theta is equal to b into. Now let us differentiate it without writing d by d theta. Okay? So b is constant, you have to keep it as it is. Now differentiate sin theta by 2. You should take it as sin theta. What is the differentiation of sin theta? Cos theta, but here it is theta by 2. And you have to differentiate this theta by 2 again with respect to theta. That is into half into, because half is constant, you can write it before d by d theta. So half into d by d theta of theta is always 1. So it is only half, right? So or dy by d theta is equal to b by 2 into cos theta by 2. Is that clear? So this is number 2. So this is number 2. Now you have to get dy by dx. So how can you get dy by dx? You have to divide 2 by 1, isn't it? Then only you will get dy by dx. But if you divide 1 by 2, you will get dx by dy. But you are asked to find out dy by dx. Now, dividing 2 by 1, right? So what do we get? Dividing 2 by 1, that is dy by d theta upon dx by d theta. That is left hand side of number 2 is divided by left hand side of number 1, dy by d theta upon dx by d theta. So here d theta will cancel, and then you will get dy by dx. Now in the numerator you should write right hand side of number 2, that is b by 2 cos theta by 2 divided by, in the denominator write down right hand side of number 1, that is minus a by 2 into this is your sin theta by 2, right? Now let us simplify it. So on the left hand side d theta will be cancelled, so it is dy by dx is equal to, now here cos theta by 2 sin theta, these two will not be cancelled, that will not be simplified, okay? But before that, cos theta by 2, before cos theta by 2 there is b by 2, and before sin by theta by 2 there is a by 2, but here these two will be cancelled, but this theta by 2 cannot be simplified, okay? So only these two will be cancelled. So what do we get? What is dy by dx? Minus b by a into, what is cos by sin? It is cot theta by 2. So minus b by a into, what is cos by sin? It is cot theta by 2. So this is the final answer. Understood? So you can copy it. We'll do the next question now. So now we will do the next question, that is 18 number 4. Here also find dy by dx. So this is a parametric equation. It is wrongly written here. That is, this is x. This is x. X is equal to a cos q theta and y is equal to a sin q theta, right? So the given equation is x is equal to a cos q theta, comma y is equal to a sin q theta. So this is also a parametric equation. So x and y are expressed in terms of a third variable theta. So theta is a parameter here. So this equation is known as parametric equation. Okay. So let us differentiate it. So first equation here is x is equal to a cos q theta. Let us differentiate it. Differentiating both the sides. Differentiating both the sides with respect to theta. So therefore dx by d theta is equal to a into, a is constant. So how can you differentiate cos cube theta? So you should take it as cos theta whole cube, right? Cos theta whole cube. Here the power is a constant. So you should take it as x to the power n. What is the differentiation of x to the power n? It is n into x to the power n minus 1. So similarly here you can write 3 comes in the front, then decrease the power by 1, that is you will get 2, that is it will be cos theta whole square, but it is cos square theta into, which function was taken as theta? Cos theta was taken as theta. Now again you have to differentiate cos theta with respect to theta. So what is the differentiation of cos theta with respect to theta? That is minus sin theta. Is that clear? So this is the differentiation, or dx by d theta is equal to, so minus sin, write it in the front, minus 3a cos square theta into sin theta. Minus 3a into cos square theta into sin theta. So suppose this is equation number 1, right? So again you have to differentiate second equation with respect to theta, that is again y is equal to a sin q theta. Again y is equal to, it is a sin q theta. Now let us find out dy by d theta here first. So differentiating both the sides, with respect to theta. So it is dy by d theta is equal to, a is constant here, only the variable, third variable or parameter is theta. So you have to differentiate with respect to theta, that is dy by d theta is equal to a into, again sin cube is there, sin theta whole cube. Actually it is sin theta whole cube. So power is a constant here, so sin theta is the variable, so it is in the form theta to the power n or x to the power n. What is the differentiation of x to the power n? N into x to the power n minus 1. But here it is 3 comes in the front, then decrease the power of sine theta by 1, you will get sine theta whole square. If you simplify it, you will get sine square theta. So in this case, sine theta is taken as x or theta. Now we have to differentiate that sine theta with respect to theta. What is it? It is cos theta. What is the differentiation of sine theta with respect to theta? It is cos theta. Okay? Or dy by d theta is equal to 3 comes in the front. Write it before a, 3a. Then it is sine square theta cos theta. So let us mark it number 2. So actually you have to find out the value of dy by dx. That means what will you do here? So what will you do with this 1 and 2 to get dy by dx? Dividing 2 by 1. So write down dividing 2 by 1, right? So let us divide 2 by 1. So what do we get? Dividing 2 by 1, what do we get? So therefore dy by dx is equal to, so write down right hand side of number 2, or you may write here dy by d theta. So dy by d theta divided by dx by d theta is equal to, you can write here, so write down right hand side of number 2, that is 3a sine square theta into what? Cos theta divided by, what was the value for dx by d theta? You can check your copy. That is, I think it was minus 3a cos square theta into sine theta, isn't it? So what was the value for dx by d theta? In number 1, it was minus 3a cos square theta into sine theta, right? So here 3a gets cancels. Sin theta and square gets cancelled, cos theta and square gets cancelled. So here also d theta gets cancelled. So what do we get? Dy by dx is equal to minus sine. What is sin theta by cos theta? It is only tan theta. So this is the simplified value of dy by dx, which is equal to minus tan theta. Okay? So we'll do the next question. So now we will do the next question, that is 18 number 5. So here also you have to find out what dy by dx, right? So this is also a parametric equation. X and y are expressed in terms of parameter t here. So let us find out dx by dt first. So here given is x is equal to t log t, right? So let us differentiate both the sides with respect to t. Differentiating both the sides with respect to t. So therefore dx by dt is equal to u rule. This is the product of two different functions, isn't it? So t is kept as it is into, what is the differentiation of log t with respect to t? It is 1 by t plus, so log t is kept as it is into, what is differentiation of t with respect to t? It is always 1. That is d by dt of t is 1. It is just like d by dx of x is 1. Okay? So here dt gets cancels. So or dx by dt is equal to 1 plus log t. So this is your number 1. Okay? So now we have to find out dy by dt next. Again y is equal to, so what is given here? Y is equal to log t divided by t. So here also y is expressed in terms of t. You have to differentiate both the sides with respect to t again. So differentiating both the sides with respect to t. Okay? So now what is dy by dt now? So therefore dy by dt is equal to, you have to use here u by v rule. Both numerator and the denominator are expressed in terms of t. Both are the variables or the parameter here. So you have to use u by b rule here. So let us keep the denominator as it is in the numerator. T into what is d by dt of log t? 1 upon t. Always put minus sign. Now log t numerator is kept as it is. It is kept same into what is the differentiation of that denominator with respect to t? That is d by dt of t is always 1. Whole divided by what? Denominator whole square, isn't it? That is your t square. So here tt gets cancels, t1s are t, t1s are t. So what do we get? So it is dy by dt is equal to 1 minus log t whole divided by t square. So we get dy by dt is equal to 1 minus log t whole divided by t square. Suppose this is number 2. Now we have to find out dy by dx at t is equal to 1. So पहिला नै हामीले t is equal to 1 हाल्नु हुँदैन. That is wrong. First of all, you have to get the value for dy by dx and then you have to put the value for t is equal to 1 always. Okay? So dy by dx को भ्यालु निकालेपछि मात्र हामीले t is equal to 1 हाल्नु पर्छ. ठीक छ? पहिला हाल्नु हुँदैन नि. ठीक छ? So now you have to divide 2 by 1 because you have to get dy by dx, isn't it? So dividing 2 by 1 now. So dividing 2 by 1, right? So write down left hand side of number 2 in the numerator, dy by dt divided by, now write down left hand side of number 1 in the denominator, that is dx by dt, which is equal to, on the right hand side, what do we get? You have to write down right hand side of number 2 in the numerator, 1 minus log t, this whole divided by t square, whole divided by, in the denominator, what should you write? That is the value for dx by dt, that is 1 plus log t. So it is 1 plus log t, okay? So now let us simplify it once again. So, or here dt gets cancels, you will get dy by dx, which is equal to, what is the numerator here? 1 minus log t divided by t square. Actually it is 1 plus log t whole divided by 1. So when this denominator goes up in the numerator, it becomes upside down into 1 upon 1 plus log t. Is that clear? That is, what is the value for dy by dx? It is 1 minus log t into 1 is 1 minus log t divided by t square within bracket 1 plus log t. Is that clear? So this is the value for dy by dx in terms of t. But in the question, you have to get the value for dy by dx when t is equal to 1. Now you have to put t is equal to 1 here. So putting t is equal to 1. So putting t is equal to 1, what do we get? Dy by dx is equal to 1 minus log t is log 1 divided by 1 square within bracket 1 plus log 1. So you should know the value for log 1. Log 1 is always 0. Log 1 base e is always equal to 0. You should know it. Okay? So log 1 base e is always equal to 0. Right? Log 1 base e is always equal to 0. Right? So here, if there is no base, the base is e out here. So therefore dy by dx. So dy by dx is equal to 1 minus, you know that log 1 is 0, divided by 1 square is 1, within bracket 1 plus log 1 is always 0, right? So if you simplify it, what will be the value for dy by dx? That is dy by dx is equal to 1 upon 1, which is equal to 1. So the value for dy by dx is equal to 1, okay? So now we'll do next question. So now we'll do the next type of question. That is, another type of question is number 20. Find the derivatives of x square with respect to log x. This is different type of question. Okay. So now in 20 number 1, you have to find out the derivative of x square with respect to log x. So how will you do it? So let us assume this first function x square as y and log x as z. So this question now becomes find the derivative of y with respect to z. That means find the derivative of y with respect to z. Mathematically it is dy by dz. Okay. Let us assume x square as y and log x as z. So this question now becomes find the derivatives of y with respect to z. That means you have to find out dy by dz. Okay. So it is just like your parametric equation. Okay. So let y is equal to x squared and z is equal to log x. That is, so how is it parametric equation? This y and z are expressed in terms of a third variable x. Now x is a parameter here. So this is also known as parametric equation. It is just like your parametric equation, right? So in this case, you have to find out the value for only dy by dz. That should be the answer. Okay. So now y is equal to x squared. So y is expressed in terms of x. So find dy by dx. So differentiating both the sides with respect to x. Okay. So therefore dy by dx is equal to, what is dy by dx of x squared? It is only 2x. So let us mark it number 1. Again, what is the second equation there? Again, it is z is equal to log x, right? So let us differentiate both the sides with respect to x. So here also write differentiating both the sides with respect to x, right? So what is dz by dx? So it is dz by dx is equal to, what is d by dx of log x? No need of writing again d by dx of log x, just directly differentiate it. Okay. So what is the differentiation of log x? It is 1 upon x. So let us mark it number 2. Okay. So now actually what is to be calculated, what is to be determined here? You have to find out the derivative of y with respect to z. That means you have to find out dy by dz, not dz by dy, right? This is y and this is z. Derivative of y with respect to z. That means you have to find out dy by dz. So how can you get dy by dz? You have to divide 1 by 2, right? So dividing 1 by 2. So dividing 1 by 2, what do we get? Let us divide 1 by 2. Write down left hand side of number 1 in the numerator. That is dy by dx. And write down, you have to write down, so in this case, this dy by dx, you have to write down left hand side of number 1 in the numerator divided by, you have to write down left hand side of number 2 in the denominator. That is dz by dx, which is equal to, on the right hand side, you have to write down right hand side of number 1 in the numerator, that is 2x divided by, and you have to write down right hand side of number 2 in the denominator, that is 1 upon x. Okay, so here dx gets cancels. What do we get? So it is dy by dz is equal to, now when you simplify it, 1 upon x, when it goes up in the numerator it becomes upside down, that is 2x into x is 2x square. So this is the answer. So what is the derivative of x square with respect to log x? It is what? 2x square. Is that clear? So that is your answer. So let's do the next question again. So now we'll do the next question, that is find the derivatives of number 4, that is log x base 10 with respect to tan inverse x. Okay, so you can use the same method as in as you have done in 20 number 1. Okay, so let's do the same method here also. Let y is equal to log x base 10 and z is equal to tan inverse x. That means you have to find out the derivative of y with respect to z. That means you have to calculate dy by dz. Okay, so therefore y is equal to log x base 10 But in this case, you cannot differentiate it directly because the base here is 10, not e. If it is log x base e, you could have easily differentiated, isn't it? That is, log x base e is 1 upon x, but the base is not e, it is 10. So, or y is equal to, this is your log x. Let us write it in terms of fraction. Now it is base e. Log x by log 10. If there is no base, the base is e. Or y is equal to, now you can take this log 10 base e to the numerator. What does it become? It is log e base 10 into log x base e. Okay. Now you can differentiate it. Log e base 10 is a constant and log x base e is the only variable here. So you can differentiate both the sides with respect to x. Now here you have to calculate derivative of y with respect to z. That means you have to calculate dy by dz. Okay. So let us differentiate both the sides with respect to x here. So differentiating both the sides with respect to x, right? So what do we get? Dy by dx. So dy by dx is equal to, among these two, log e base 10 is a constant, right? Log e base 10. Log e base 10 into, what is dy by dx of log x base e? It is 1 upon x, right? So what is dy by dx of log x base e? It is 1 upon x. Here, so here log e base 10 is a constant. So it is number 1. Let us mark it as number 1. Okay. So again, what is the second one? Second function. Again, z is equal to tan inverse x. Again, z is equal to tan inverse x. So let us find out dz by dx now. So differentiating both the sides with respect to x, right? So dz by dx. So dz by dx is equal to, now no need of writing d by dx of tan inverse x, just write down the differentiation of tan inverse x with respect to x. So what is the formula? It is 1 upon 1 plus x square. That is, tan inverse x differentiation is 1 upon 1 plus x square. Okay. So now you have to calculate, or you have to determine dy by dz, isn't it? You have to find out dy by dz now. So how can you get dy by dz here? Dx will be cancelled. That means you have to divide 1 by 2. So dividing 1 by 2. So what do we get dividing 1 by 2? That is dy by dx upon dz by dx is equal to. Now on the right hand side, you have to write down right hand side of number 1 in the numerator. That is log e base 10 into 1 upon x whole divided by, in the denominator, you should write down right hand side of number 2. That is 1 upon 1 plus x square. Is it clear now? This is 1 divided by 2. You have to calculate dy by dz. So it is log e base 10 into 1 by x in the numerator divided by 1 upon 1 plus x square is in the denominator. So now let's simplify it. So it's only dy by dz, which is equal to dx will be cancelled. Now 1 plus x square goes up in the numerator. Let us write it first. 1 plus x square into log e base 10, right, whole divided by what? It is x. So this is your final answer. Understood? So you can copy it. We'll do the next question now. So now we'll do another type of question. Find the derivatives with respect to x. Now this is another type of question, that is, you have to differentiate log sin x base x with respect to x. Okay. If it happened to be log sin x base e, you could have easily differentiated using log x base e. But here the base is given as x, that is also a variable, right? So if that variable x is given as a base, you should write it in terms of fraction. You know how to write this term in terms of fraction. You know that log sin x divided by log x, and the base will be there, e. The base will be e there, isn't it? So you can differentiate now. So let us write first, let y is equal to log sin x base x. अब यो अलिकति different type को questions. कसरी different type को भन्दाखेरि log sin x base x छ. यदि त्यो base e भएको भए हामी के गर्थ्यौ, डाइरेक्ट डिफरेन्सिएट गर्थ्यौ. log x base e लिएर डाइरेक्ट डिफरेन्सिएसन हुन्थ्यो. तर base e छैन, base e को जग्गामा यहाँ के छ, x छ. त यस्तो छ भने चाहिँ हामीले के गर्नुपर्छ, you have to write it in terms of fraction. So how can you write it? You know how to write it in terms of fraction. You know that log of sin x divided by log x. So here, if there is no base, the base is e. No need of, it's not necessary to write e out there, or you may write it e also. यदि नलेख्दा पनि हुन्छ, लेख्यो पनि हुन्छ, केही फरक पर्दैन त्यसले. बुझ्यो? यदि तिमीले लेखेन छ भने अटोमेटिकली के बुझिन्छ, त्यहाँ e छ भनेर बुझिन्छ. बुझ्यो? So let us differentiate it. Now u by v rule, you have to use u by v rule, right? So write down differentiating both the sides with respect to x, right? So therefore it is dy by dx is equal to, now u by v rule. Now which function is kept as it is? That is the denominator log x base e into. Now differentiate the numerator. So how can you differentiate log sin x base e? It is just like your log x. This sin x is taken as x, so it is log x. What is the differentiation of log x? 1 upon sin x into. Again differentiate the function which is assumed as x. Your sin x हामीले x सोचेको, त्यसको differentiation कति हुन्छ? Cos x. Is that clear? So minus. Now you have to keep this numerator as it is, that is log of sin x base e into, right? Now differentiate the denominator, that is log x base e. What is this differentiation? It is 1 upon x, right? Whole divided by, what is the rule now? You have to write down whole square in the denominator, that is denominator whole square, that is log x base e whole square. So this is your u by v rule. Is it understood? Now let us simplify it. Or dy by dx is equal to, now in the numerator, you know that cos x by sin x is, you can write cot x into, next you write log x base e minus, now it is 1 by x, log of sin x, the base is e, whole divided by what? It is log x base e whole square. Now it is simplified, okay? Now in the numerator you can take the LCM, or dy by dx is equal to. So what's the LCM in the numerator? In the numerator, what's the LCM? It is x, right? So in the numerator it will be x cot x into log x base e minus log of sin x base e. So now in the numerator LCM is taken. What's the LCM? It is x. Now x is multiplied by this term, that is x cot x log x base e minus log sin x base e, whole divided by, it is log x base e whole square. So actually what is the term below log x base e whole square? It is 1, right? Now simplify it. So what will be in the next step? Or dy by dx is equal to, now it is x cot x log x base e minus log of sin x base e whole divided by x. This is in the numerator, into what? Into, now when this log x base e whole square upon 1 goes up in the numerator, it becomes upside down. So what do we get now? Into 1 upon, it is log x base e whole square. Is that clear now? So write down the final answer. What is the final answer? So dy by dx is equal to x cot x into log x base e minus this is log of sin x base e whole divided by, you have to multiply these two expressions, x into this is log x base e whole square. So this is your final answer. Is it clear to all of you? So I think you have understood it. You can copy it. We'll do the next question now. So now we'll do the next question, that is 2 number 4. You have to find out the derivative of this function, that is log of sec x base is sin x plus 10 to the power x square. So let us assume this function as y. So here also log sec x base sin x is there. Here base is also the variable. If base is also the variable, you should write it in terms of fraction, then only you can differentiate it. That is, we are making the base of logarithm e, right? So or y is equal to log of sec x divided by log of sin x. And here if there is no base, what is the base here? The base is e plus it is 10 to the power x square. Is that clear? Now you can differentiate both the sides with respect to x. Okay, so differentiating both the sides with respect to x. So therefore dy by dx is equal to, now we can use here u by v rule, both are variables here. Now denominator is kept same, log of sin x base e into, now differentiate the numerator. What is the differentiation of log sec x? Take it as log x. So it is 1 by sec x into what? Again differentiate the term which is assumed as x. Again you have to differentiate sec x. What is it? Sec x tan x. It is sec x tan x, right? Log sin x is kept as it is, log sin x base e. Now differentiate log sec x. What do we get? 1 by sec x into, again differentiation of sec x is sec x into tan x. Then comes minus sign. Now you have to keep the numerator same, that is log of sec x, and here the base is e into, now differentiate the denominator. What is the denominator here? Log sin x. It is just like your log x. What is the differentiation of log x? 1 upon x, but it is 1 upon sin x into, now again differentiate sin x with respect to x because that was assumed as x. So what is the differentiation of sin x? It is cos x. Is that clear? So whole divided by, in the denominator, what should you write? Denominator whole square. That is within second bracket log sin x. What is the base here? Base is e whole square. Right? Plus. Again you have to differentiate this term, that is the second term, 10 to the power x square. How will you differentiate it? Your base 10 is a constant, x square is the variable. You should take it as a to the power x. What is the differentiation of a to the power x? You know that a to the power x log a base e. But here it is 10 to the power x square into log a. Log a means here log 10 base e into. Again you have to differentiate the function which is assumed as x. In this case x square was assumed as x. So what is this differentiation? What is the differentiation of x square? It is 2x to the power 1. That means you have to decrease the power by 1. So what do we get? It is into 2x. Is that clear? So that is the differentiation of the second term, that is 10 to the power x square. Right? So now, in the next step, or dy by dx is equal to, so here sec x gets cancels. What do we get? It is tan x. Let us write tan x first, then write down log of sin x base e. Log of sin x the base is e, then comes minus sine. What is cos x by sin x? It is cot x. It is cot x into log of sec x. Log of sec x, the base is e. So whole divided by, in the denominator, what do you write? Denominator whole square, that is log of sin x base e. That is your whole square. Plus, what is the second term out here? Let us write 2x first. Okay. So 2x into, then 10 to the power x square. It is 10 to the power x square into, it is log 10 base e. So this is the final answer. So I think you have understood it also. So you can revise it at home. Okay. So we'll do the next question. So now we'll do the next question. Find the derivatives with respect to x of this function. That is question number 3. So this is your inverse circular function, tan inverse within bracket cos x divided by 1 plus sin x. And plus sine of log x is there. Okay. So let us assume it as y is equal to tan inverse within bracket cos x by 1 plus sin x bracket closed, then it is sine of log x. Okay. So let us simplify the first function here, because this is in terms of inverse circular function. You can simplify it and then you can differentiate it, and keeping the second term as it is. You can keep the second term same. Let us simplify the first term, or y is equal to tan inverse. Now write down within second bracket, what is the formula for cos x? In trigonometry, so you should write the formula from sub multiple angle. So what is the formula for cos x? It is cos square x by 2 minus sin square x by 2, right? Whole divided by, instead of 1 you should write cos square x by 2 plus sin square x by 2, then plus. What is sin x formula? It is 2 sin x by 2 cos x by 2. Is that clear? So second bracket is closed. Then write down this second term. Second term remains same. You cannot simplify second term, isn't it? So keep it same. That is sine of log x. So let us simplify the first term here. Y is equal to tan inverse. Now within second bracket, what is the formula? A square minus b square. That is from algebra. So it is a plus b into a minus b. That is cos x by 2 plus sin x by 2 into a minus b. What is a minus b here? Cos x by 2 minus sin x by 2, right? So whole divided by. So now this is the formula, a square plus b square plus twice ab. What is the formula? A square plus b square plus twice ab. A square plus b square plus twice ab. What is the formula here? A plus b whole square. So it is cos x by 2 plus sin x by 2 whole square. And here second bracket is closed. Then plus, it is sine of log x. So I think you have understood it. We are just simplifying it. Now here you can cancel cos x by 2 plus sin x by 2, and square gets cancels. So you can cancel them. Okay. Next. Or y is equal to tan inverse. So what are the remaining terms here? It is cos x by 2 minus sin x by 2 divided by cos x by 2 plus sin x by 2 plus sine of log x plus sine of log x. Okay. So now what will you do now? Now since this is your tan inverse, you should write it in terms of tan, because you should get here tan inverse tan x form. so that you can write only x, but you won't get tan x here. You will get different terms here. Okay, so let us convert this fraction in terms of tan. That means you have to divide both the numerator and the denominator by cos x by 2, isn't it? Or y is equal to tan inverse. So in the numerator, divide by cos x by 2, and then you can separate the term. What do we get? Cos x by 2 divided by cos x by 2, 1 minus, this is your tan x by 2 divided by cos x by 2 divided by cos x by 2, that is also 1, plus, what is tan x by 2 divided by cos x by 2? That is also tan x by 2, bracket closed. Then plus, it is sine of log x, right? So now what will you do now? You can convert it into formula form, tan a minus tan b upon 1 plus tan a tan b. So you should write this one in terms of tan. What is 1 in terms of tan? It is tan pi by 4. You know that tan pi by 4 is always 1. So y is equal to tan inverse within bracket. Here 1 is tan pi by 4 minus this is tan x by 2 whole divided by what do we write? 1 is kept as it is, 1 plus, actually it is 1 into tan x by 2. So instead of that 1, what can you write? Tan pi by 4 into tan x by 2, right? So bracket is closed. So this is the form tan a minus tan b divided by 1 plus tan a tan b. Then plus, you should write here sine of log x. Is that clear to all of you? So, or y is equal to, this is your tan inverse. So what is the formula in this case? From compound angle, tan a minus tan b upon 1 plus tan a tan b. What is the formula? Tan of a minus b. So it is tan of, what is a minus b out here? It is pi by 4 minus x by 2. Then plus, what should you write here? Sine of log x. Is it clear? Now, what is the formula? Tan inverse tan x form is there. Instead of x, what is here? It is pi by 4 minus x by 2. Okay? So next, or y is equal to, now it is tan inverse tan x form, that is x. What is x here? Pi by 4 minus x by 2. Then you write plus sine of log x. So I think you have understood it. So it is the simplified form of the given expression. Now we can differentiate it easily. So differentiating both the sides with respect to x. So what do we get? Dy by dx is equal to, this is constant term pi by 4. What is differentiation of pi by 4 with respect to x? It is 0. Don't have to write it. So now this x is with minus half. Minus half is constant. So minus half comes in the front into what is d by dx of x? That is 1. You don't have to write 1 because minus half into 1 is always minus half. Plus, now this is just like your sine x. You should take it as sine x. What is the differentiation of sine x? It is cos x. Cos of what is x here? It is log x. Again, you have to differentiate the term which is assumed as x. So in this case, log x was assumed as x. So what is the differentiation of log x? It is 1 upon x. So write down the final answer now. What is the final answer now? That is dy by dx is equal to, it is minus half plus, let us write 1 by x first, into cos of log x. Into cos of log x. So this is the final answer. Understood? So you can copy it. Let's do the next question now. So now we will do the next question, that is find the derivative with respect to x of the function 1 plus x whole to the power x. This is the number 1. So first of all you have to write y is equal to 1 plus x whole to the power x. So now in this case, this is the base 1 plus x. So since it is in terms of x, this is the variable, the base is the variable, power is also x, that is the variable. If both bases and powers are variables, you have to take log on both the sides. I told you this one, isn't it? Because this x should come in the front. Then only you can differentiate it. So what is the method that x comes in the front? You have to take log on both the sides. So first of all, assume let y is equal to 1 plus x whole to the power x. Then you have to take log on both the sides. मैले अस्ति अनलाइन क्लास पनि भनेको थिएँ हैन. सो प्रिभियस अनलाइन क्लासमा मैले के भनेको थिएँ भन्दाखेरि यदि बेस र पावर दुईटै भेरिएबल छ भने चाहिँ तिमीले के लिनु पर्छ, लग लिनै पर्छ. बुझ्दैन? बट फर्स्ट अफ अल यु हैव टु एज्युम y is equal to that given function, that is 1 plus x whole to the power x. Now take log on both the sides. किनभने यो x चाहिँ कता आउनु पर्यो, अगाडि आउनु पर्यो. यो अगाडि कसरी आउँछ, लग लगाएर मात्रै आउँछ. त राइट साइडमा मात्रै लग हैन, तिमीले लेफ्ट साइडमा पनि लग लगाउनै पर्छ. सो taking log on both the sides, taking log on both the sides. So what do we get? This is log y is equal to log 1 plus x whole to the power x, right? So now, or it is log y is equal to, now x comes in the front. Because of this log, you know properties of logarithm, that is log x to the power n is always n log x. Similarly, this x becomes the coefficient of log x into log of 1 plus x. Now you can easily differentiate it. So write out differentiating both the sides, with respect to x. Okay, so therefore now we are differentiating both the sides with respect to x. So what is d by dx of log y? So first of all, it is in the form of log x. What is the differentiation of log x? It is 1 by y, but in this case it is 1 by y. This y was assumed as x, isn't it? Again you have to differentiate y with respect to x. So what is it? It is dy by dx, which is equal to, now on the right hand side, x into log of 1 plus x is there. You have to use UV rule, you know that, isn't it? X into x is kept as it is. What is the differentiation of log of 1 plus x? You should take it as log x. What is the differentiation of log x? It is 1 upon 1 plus x. But in this case, x is 1 upon x is 1 plus x. Okay, so it is 1 upon 1 plus x. In this case, x is 1 plus x. So you should write here 1 upon 1 plus x. Again differentiate the term which is assumed as x. That is 1 plus x was assumed as x. So what is the differentiation of 1 plus x again? For 1 it is 0 plus, what is the differentiation of x with respect to x? That is always 1. So 0 plus 1 is always 1. So you don't have to write 1 out there. Okay? Then plus, which function is kept as it is? That is log of 1 plus x into, now differentiate this term x with respect to x. What is it? It is always 1. So that is your UV rule. Okay? So or dy by dx is equal to y goes to the denominator, so you can cross multiply it. So y within bracket, what do we get? X upon 1 plus x plus, so it is 1 into log of 1 plus x is log of 1 plus x. But in this case you have to put the value for y on the right hand side, because we have assumed 1 plus x whole to the power x as y. So on the right hand side you have to put the value for y. Okay, so or dy by dx is equal to, what is the value for y in this case? It is 1 plus x whole to the power x. Then within bracket what do we get? X upon 1 plus x plus log of 1 plus x. So this is the final answer. So I think you have understood it. If the variables and the powers, if the base and the powers are both variables, then you have to take log. First of all, you have to assume that given function as y, and then you have to take log on both the sides. So I think you have understood it. So we'll do the next question now. Now let's do the next question. Find Find the derivatives with respect to x of the function x to the power cos square x. Again, both the base and the powers are the variables here. Both the base and the powers are the variables. So you should take log here. So first of all, you have to assume this x to the power cos square x as y. So this is question number 4.3. Let y is equal to x to the power cos square x. So you have to take log on both the sides. Taking log on both the sides, right? So what do we get? Therefore, log y is equal to log x to the power cos square x, or log y is equal to, now you can use the properties of logarithm here. This power becomes the coefficient, that is cos square x into log x, right? Now we can differentiate both the sides with respect to x. So differentiating both the sides with respect to x. Let us differentiate it. So therefore, now what is the differentiation of log y with respect to x? First of all, it is log x form. Log x ko differentiation kati bhayo? 1 by x. But it is y there. So it is 1 by y. Again you have to differentiate the term which is assumed as x. That is, y was assumed as x. And differentiate y with respect to x. What is it? 1 by y into dy by dx is equal to. Now on the right hand side, you can use UV rule. You know UV rule, cos square x is kept as it is. Log x differentiation is 1 upon x plus. Now log x is kept as it is. Log x into, now what is the differentiation of cos square x? First of all, the power is a constant here. So this is cos x whole square. Cos x is the variable. So you should take it as x. So it is in the form x to the power n. What is the differentiation of x to the power n? N into x to the power n minus 1. But what is the differentiation of cos square x here? It is, first of all, 2. 2 comes in the front. Here x is cos x. So it is cos x whole to the power 1. Cos x whole to the power 1 is always cos x. So 2x form is there, isn't it? That is 2 into cos x. Again, you have to differentiate the term which is assumed as x. That is, cos x is assumed as x. That means you have to differentiate again cos x. What is the differentiation of cos x? Into minus sin x. Is that clear? So let us simplify it. 1 upon y into dy by dx is equal to what? It is cos square x upon x, right? Plus and minus. You should write minus there. Then write down log x. So it is log x into, again, what is that? 2 sin x cos x. What is it? 2 sin x cos x from multiple angles is sin 2x. So this is your sin 2x. Okay. Now we have to find out the value for only dy by dx. So cross multiply by y here. Or dy by dx is equal to y within bracket cos square x upon x minus, it is log x into what? It is sin 2x. Bracket is closed. So now on the right hand side you have to put the value for y, because we have assumed y is equal to x to the power cos square x. So on the right hand side only you put the value for y. So over, it is dy by dx is equal to, what is the value for y in this case? It is x to the power cos square x, isn't it? So x to the power cos square x. So within bracket, what do we get? It is cos square x divided by x. Then minus, what do we write? It is log x into sin 2x. So this is your final answer. Is it understood? So you can copy it. We'll do the next question now. Now, we will do the next question, that is number 4. Find dy by dx when x to the power y is equal to e to the power x. since you have to find out dy by dx, that is y and x both are the variables here. Okay, so x is the variable, y is also the variable. If both the variables are there, if the base and the powers are the variables, you have to take log on both the sides. So let us take log on both the sides. So you have to take log on both the sides. So taking log on both the sides. So what do we get? Log x to the power y is equal to log e to the power x. Now, because of this log, powers becomes the coefficient. That is, y log x is equal to x log e. Right? So you know that what is the value for log e? Log e matlai cha bhane log e base e ho. You know that if log a base a is there, you can write it in terms of fraction log a by log a, which is equal to what? 1. Similarly, what is log e? Same base e is there, so log e base e is always 1. So log e bhaneko 1. ठीक छ? Because if there is no base, the base is e. That means what is the value for log e? That is always 1. Or y log x is equal to whatever, that is x, right? So in this case, you can differentiate directly with respect to x. Let us differentiate it directly. Differentiating both the sides. Differentiating both the sides with respect to x, right? So we are differentiating both the sides with respect to x, okay? So it is y into 1 by x. UV rule is applied. Y is kept as it is into d by dx of log x is 1 by x plus log x into what? Now log x is kept as it is. Now differentiate y with respect to x. What is it? It is dy by dx. Now in this case, UV rule is used. Is equal to, what is dy by dx of x? It's always 1, right? Or now let us get the value for dy by dx. Log x into dy by dx is equal to 1 minus y by x, right? Or what is log x into dy by dx now? Dy by dx is equal to, what's the LCM here? The LCM is x, so x into 1 is x minus y, right? So get the value for dy by dx, or dy by dx is equal to, what is it? It is x minus y divided by x log x. So I think you have understood it, okay? Or you may simplify it further, okay? So you can keep the answer as it is also. That is also the answer. That is, what is the value for dy by dx is equal to x minus y whole divided by x log x. Or you may simplify it further. So from here, what is the value of log x? It is x upon y, isn't it? You can put that value of log x here. So let us get the value for log x here. From here, what is the value for log x? Log x is equal to x upon y, right? Log x is equal to y goes to the right hand side, but you should write it in the denominator. So what is the value for log x is equal to x upon y. So let us put it here now. Now therefore, dy by dx is equal to x minus y whole divided by, so x into what is log x here? Log x to value here, it is x upon y, right? Or dy by dx is equal to, now y goes up in the numerator when you simplify it, so y into x minus y whole divided by, what is x into x? X square. That is, y goes up in the numerator and it is multiplied by x minus y. That is y into x minus y whole divided by x into x is x square. So you can write it. You can also write down this as an answer. Is that clear to all of you? So you have understood it. So you can copy it. Let's do the next question. So now, Let's do the next question. That is, find the derivatives with respect to x. That is question number 5. X to the power x whole to the power x is there. So let us assume let y is equal to x to the power x whole to the power x. X to the power x whole to the power x. Can you simplify it? What happens to these powers x and x? It can be multiplied because it is given as x to the power x whole square whole to the power x is given. X to the power x whole to the power x is given. That's why you can multiply these two powers. Okay, x to the power x whole to the power x is given. That's why you can multiply these two x. Therefore, y is equal to x to the power x square. Now you can easily do it. Both the base and the powers are the variables here. So that power should be taken to the front. So you have to take log on both the sides. What is the method here? You have to take log on both the sides because both the base and the powers are the variables here. Okay. So taking log on both the sides. Taking log on both the sides. Taking log on both the sides. What do we get? Log y is equal to log x to the power x square. Or log y is equal to x square comes in the front, isn't it? So you log ले गर्दा चाहिँ यो power x square के हुँदैछ अगाडि आउँदैछ. That is the properties of logarithm. Is that clear? Now you can differentiate both the sides with respect to x. So differentiating both the sides with respect to x. Okay. So what do we get? What is the differentiation of log y with respect to x? What is the method of writing log y differentiation with respect to x? It is 1 by y into dy by dx. पहिला के फर्म आयो? log x फर्म आयो. Log x को differentiation 1 upon x. तर x भनेको y छ. So 1 upon y into यो y लाई नै हामीले x मानिलिएको हो. त्यसलाई फेरि डिफरेन्सिएट गर्नु with respect to x. That is dy by dx is equal to. So on the right hand side, x square log x. So you can use UB rule. So x square is kept as it is into, what is the differentiation of log x with respect to x? 1 upon x plus log x is kept as it is into, what is the differentiation of this x square? That is 2x, right? Is that clear to all of you? So here you can cancel this x and square gets cancels, or 1 upon y into dy by dx is equal to, what do we get? X plus, this is only x. So 2x, you first write 2x and then log x, right? So now you can cross multiply. So dy by dx is equal to y within bracket x plus 2x log x. Now put the value for y. So what is the value for y here? Or dy by dx is equal to, what is the value for y in this case? It is x to the power x square, x to the power x square, right? That is the value for y. And from here you can take common. What is common out here? X is taken common. So within bracket 1 plus 2 log x. That is you can put the value for y. That is x to the power x square into x into within bracket 1 plus 2 log x. So this is the final answer. So you can put the value for y here, isn't it? X to the power x square. Then x is common out here, that is x, and within bracket there is 1 plus 2 log x. So that is your final answer. So you can copy it. We'll do the next question. Now, we'll do the next question, that is, find the derivatives with respect to x of the function, that is for number 6, tan x whole to the power sin x when x is equal to pi by 4. So let us assume this given function tan x whole to the power sin x as y. Okay? तर यसमा हामीले x is equal to pi by 4 दिएको छ. यो पहिला नै x is equal to pi by 4 हाल्नु हुँदैन because you will get constant and its differentiation is always 0. त पहिला नै हाल्नु हुँदैन. त पहिला चाहिँ हामी के गर्छौं dy by dx निकाल्छौं अनि लास्टमा मात्रै x is equal to pi by 4 हाल्छौं. So let us assume let y is equal to tan x whole to the power sin x. Okay? So now these both bases and powers are the variables here. So if the bases and the powers are the variables, you cannot differentiate it directly. If the bases and the powers are the variables, you cannot differentiate it directly. That is, यो sin x लाई चाहिँ अब हामी के गर्छौं sin x लाई चाहिँ अगाडि ल्याउनु पर्यो. That means you have to take log on both the sides. Okay? So taking log on both the sides. Taking log on both the sides. So what do we get? Log y is equal to log of tan x whole to the power sin x. Okay? Or this is log y is equal to, now because of this log you can take this sin x to the front. That means sin x becomes the coefficient. Okay? Because this is the properties of logarithm, right? So sin x becomes the coefficient of log of tan x. Is that clear? So write down differentiating both the sides with respect to x. So now let us differentiate it. So now what is the differentiation of log y with respect to x? You know that it is 1 upon y into dy by dx is equal to, now sin x into log of tan x is there. You have to use uv rule. Sin x is u, log of tan x is v. You can use uv rule here. So what is the differentiation of sin x? Let us differentiate sin x keeping log of tan x same. That is, what is the differentiation of sin x? Cos x into log of tan x remains same. Cos x into log of tan x. Log of tan x. Then plus, now sin x is kept as it is. Sin x into, now how do you differentiate log of tan x? It is just like your log x. What is the differentiation of log x? 1 by x. But here it is 1 by tan x. So it is 1 by tan x into. Is that clear? Again you have to differentiate the term which is assumed as x. In this case tan x was assumed as x. So what is the differentiation of tan x? It is sec square x. Right? So it is sec square x. Is that clear now? So let us simplify it. Or 1 upon y into dy by dx is equal to, it is cos x log of tan x plus, so let us simplify it. That is sin x into, what is 1 by tan x? It is cot x. But what is cot x? It is cos x by sin x into, again what is sec square x? 1 by cos square x, right? It is 1 by cos square x. Is that clear? Sin x 1 by tan x भनेको cot x. What is cot x? Cos x by sin x into what is sec square x? 1 by cos square x, right? So here you can cancel these sin x and cos x and square gets cancels. Or 1 upon y into dy by dx is equal to, so write down the first term. What is the first term here? It is cos x log of tan x plus. Now what is the second term out there? It is 1 by cos x. 1 by cos x means it is sec x. 1 by cos x is always sec x, isn't it? So what is the value for dy by dx now? So dy by dx is equal to, now cross multiply by y. So y within second bracket cos x log of tan x plus it is sec x. So here second bracket is closed. So now let us put the value for y first. Or dy by dx, so let us write it here. or dy by dx. Now we have to put the value for y. What was y actually? It is tan x whole to the power sin x, right? And then within second bracket, what do we get? It is cos x into log of tan x. It is cos x into log of tan x, then plus sec x. Then you have to write plus sec x. Here second bracket is closed. So on the right hand side, we have substituted the value for y. Okay, so what is the value for y on the right hand side? It is tan x whole to the power sin x. So this is your dy by dx, but you have to find out the value for dy by dx when x is equal to pi by 4. Now you will put x is equal to pi by 4. So putting x is equal to pi by 4. So therefore dy by dx is equal to, this is your tan pi by 4 whole to the power sin pi by 4 within second bracket. What do we write? Cos pi by 4 log of tan pi by 4 plus sec, it is pi by 4. Is that clear? Now let us simplify further. Or dy by dx is equal to, what is tan pi by 4? 1. Whole to the power, what is sin pi by 4? That is sin 45 degree is 1 by root 2. And what is cos pi by 4? Again it is 1 by root 2 into, this is your log 1, tan pi by 4 is 1, plus what is sec 45? Pi by 4 is 45, what is sec 45? It is root 2. Is that clear? So now, which is equal to, what is 1 to the power any number? 1 to the power जतिसुकै number होस् जहिले पनि कति हुन्छ त्यो 1 हुन्छ. Within second bracket 1 by root 2 into log 1, always it is 0, log 1 is always 0, plus root 2 plus root 2, second bracket is closed. So which is equal to 1 within bracket, 0 into 1 by root 2 is 0, 0 plus root 2 is root 2, which is equal to, what is the answer? The answer is root over 2. So this is an important question. Okay, so I think I've understood it. You can copy it. So now I'll give you the homework, right? So now, these are your homework. You have to find out dy by dx for 18 number 3. Then this is the parameter equation, x is equal to 80 square, comma y is equal to 80. Here t is a parameter, so you can easily find it. And number 20, find the derivatives of number 2 and 3, tan x with respect to log x, and number 3, cot x with respect to cosec x. And this is from the next section, that is each question carries 4 marks, this one, okay. Find the derivatives with respect to x. Number 2 is log x base sin x. Number 3, log tan x base x, okay. And in this case also, this is number 4, find the derivatives with respect to x, that is, for number 2 is x to the power sin x. You have to take, you first assume y is equal to x to the power sin x and then take log on both the sides. For all these problems, same method is used, okay. So for number 2 is x to the power sin x, number 7 is x to the power cos inverse x, number 8 is x to the power e to the power x, and number 9 is log x whole to the power cos x. So you can do it at home. So first of all, you revise all the problems that we did today and do this homework. So it will be easier for you to do this homework if you revise all the problems that we did today, okay. So in the next class, we will do different types of problems, okay. So this much is for today.